Why water is the weirdest liquid on Earth. Water breaks the rules that most substances follow. Typically, things shrink when they get cold. Water doesn't behave this way. It reaches its maximum density at 39.2 degrees Fahrenheit. After that, it starts to expand again. This unusual property is why ice floats on water. If it didn't, our oceans would freeze from the bottom up. Speaking of ice, it's less dense than liquid water. That's not normal. Even Galileo was puzzled by this phenomenon. In 1612, he wondered if ice might be water rarefied rather than condensed. Water's weirdness doesn't stop there. Its boiling and freezing points are way off from what they should be. Based on the H2O formula, water should boil at -112 degrees Fahrenheit and freeze at -148 degrees. In reality, it boils at 212 degrees Fahrenheit and freezes at 32 degrees Fahrenheit. This wide liquid range is crucial for life as we know it. It's the only substance found naturally on Earth in solid, liquid, and gas forms. Another unique feature of water is its surface tension. It's the highest of any liquid, except mercury. This property allows water droplets to form beads. It's also why some insects can walk on the water's surface. But why is water so weird? It's all about molecular structure. Water molecules form strong hydrogen bonds with each other. These extensive bonds give water its sticky behavior. They also allow it to act as both a lubricant and an adhesive. Scientists have been studying water's structure for over a century. Recent research suggests that liquid water isn't uniform. It's actually a mix of two different structures. One is light and tetrahedral. The other is dense and disordered. These structures are constantly shifting and changing. This dual nature might explain why water expands when cooled below 39.2 degrees Fahrenheit. Water behaves even more strangely at extreme temperatures and pressures. At very low temperatures, water enters a no-man's land state. Here it rapidly shifts between two forms. One form is high density, and the other is low density. Scientists have struggled to study this for years. The changes happen too fast for normal tools to catch. Recently, researchers used ultra-fast X-ray lasers to observe this phenomenon. These lasers can take snapshots in tiny fractions of a second. At high pressures, water acts differently too. It can form unusual ice structures. Some of these ices are denser than liquid water. Others have exotic crystal structures. In some conditions, water might even become metallic. All this makes water essential for life. Its expansion when frozen helps shape our planet by breaking apart rocks. Its ability to dissolve many substances is vital for cells. It carries nutrients and removes waste. Water's high specific heat helps regulate body temperature. It also stabilizes Earth's climate. Its unusual density properties drive ocean currents. Even the way it flows through our veins is thanks to its unique properties. Researchers are still uncovering water's secrets. Some think water might play a role in consciousness. Others are studying how water's properties change in microgravity. This is still an active area of study.